let's try to understand what happens when you run docker build command. Okay, docker build command. Alright, so we have an docker file, right? This is my docker file that is there. Okay, this is my docker file. When we run docker build command, right, docker build some tag, right, with this command what happens, basically this command create an image, whatever we have mentioned in docker file, everything get inside this docker image. This is our docker image, but that is fine. But one more thing, I mean, in docker file, what basically inside the docker file? Set of instruction, right? Set of instructions. Set of instructions of what? This set of instructions are basically to what? Like, what is my base image, right? Copy some file, right? Or install some package, or expose a port, right? These are the instruction, right? Expose port, and also we mention, right, what command to start a container. Okay, what is, or we can say what is the code or program to start container with, right? This is what, at a nutshell, I can say these are the things that is basically the set of instruction. Now you tell me, can we copy something? Say for example, this is my, oh sorry, I have installed it, I have created here. This is not our page, right? This is a rough diagram. So what I can do here is I can paste it here, but it will go. One second, let me, oops, Control C. Something, just give me a second, let me fix it. Just give me a second, got dropped somewhere in between. I think here, right? Yeah. So this is what, like, these are the some kind of instruction in the docker file, right? We have created a docker file. Docker file is a set of instruction, but set of instructions are this. Now you tell me, say for example, I have a laptop. Okay, I am telling you to copy some files, install some software, or open some port, but the laptop is shut down. Can you do this? If the laptop is shut down, can you install any package or any software on it? Is it possible? The answer is absolutely no, right? We cannot install anything if machine is down, right? So in order to install anything or something, machine must be up and running, right? Up and running, then only I can install. Or if these instruction, like what I have mentioned, there's something known as docker file. Docker file is set of instruction. From here we create something known as docker image, and docker image will have all those things get installed. So now remember this concept, we cannot install anything if something is down. Machine must be up and running, whether it's a laptop, desktop, server, physical machine, or container. Now let's go and read this output that I have copied, and I told you that I'll come back and explain you line by line. This is the moment we run the docker build command, right? Line number 512. remove these lines. This is just a warning message. So from line number 14 you will say sending the build context ... 1 of 6. It says 1 of 6, step number 1 of 6. Then it says step number 2 of 6. Then it says step number 3 of 6, 4 of 6, so on and so forth, 5 of 6 and 6 of 6, right? 5 of 6 and then 6 of 6. Why there are 6? Because there are total 6 statements in my Docker file. 1, 2, 3, 4, 5, 6. So whatever we have mentioned in Docker file, it will go run one by one. The first statement says from, this is my base image, right? This is my base image. Okay, so this base image is basically, you can see here, it is the first statement is downloading that base image. You can see from Python it is pulling means it is downloading, pull complete, pull complete, pull complete, and finally this base image got downloaded. This is the image ID. If I show you B something, right, this is the image ID B56 that got downloaded. This is the Python image. So the first command is, step 1 of 6 is download the base image, because it's running the it's running the from statement. It's running the from statement, right? Fine, that is still fine. Then it says create work dir. Then it says create a directory /app. Then it says running this and removing this, a container. So this is what you need to understand. First what it did, it created a base image. It created a base image. Now on this base image, a directory needs to be created /app. Okay, can you create a /app directory just on image? Image is not a running form of it. So what Docker does, basically, Docker is a smart guy. It says, okay, fine, let me create a temporary container out of this image. That is the temporary container. And let me create an image there. And then when the image will get created, I will delete this container. This is how it is creating the second layer of your image. It has an app directory that got created. The moment the app directory got created, because we cannot create anything on a shutdown, on a down machine, right? That concept is clear. So what it does, it create a temporary container, it create a directory. That is what we are getting. That is why we are getting this message. You can read it. Running in means somewhere it is running. But what is this? It is a container, because the next message says removing the intermediate container. /app got created. Then I need to copy something inside app. Again, if I need to copy something inside that, again I need to create I cannot copy something on a dead machine, on a shutdown machine. I need to create, a machine must be running. So again it's creating a temporary container and creating a third layer of your image. Keep this concept in mind and read it again. Then it says run this. This is my fourth command of Docker file. Then it is again creating a temporary container with ID 547. It is installing Flask, it is installing our second dependency, blah blah blah, so many things, software is getting installed. And then it says, okay, it is done. Now I am removing the 547, the temporary container. Okay, then again I need to expose a port. Then again it's creating a temporary container, exposing a port, creating the next layer of my image, so on and so forth. It is going on and on. And then it is whatever the command you are mentioning, whatever the instruction that you are mentioning in the Docker file, it creates a temporary container to run that instruction. And when everything get installed or created or copied, it shut downing that particular, deleting that container. That's an intermediate container, a temporary container. And then this is how your image got created. So now if I go here, okay, and see, if I go back here, so how this image is getting created? So your image is getting created something like this. This is your base image. Then it is creating one more layer on top of it. It is creating one more layer. Then one more layer. Depending upon how you have written the Docker file, it will create number of layers on top of it. For each layer, because anything creation, deletion, copy, paste, whatever, any instruction, I need a machine to be running. So that's the reason Docker creates an intermediate container in between and run your instruction, whatever you mention in your Docker file. And till it reaches the last instruction, your image is now collection of layers. Okay, your image is basically collection of layers that we use. Okay, are you folks with me so far? Are you getting it? What I'm trying to explain? Is it making sense? All right. Okay, so what happens basically when you create a container, okay, and if you go now here, Docker images, let me go to my this machine, Docker images. So you'll see this is the image, and if you do Docker inspect this v200, it will give you the detail of this image. You can see all these are the layers. This is layer 1, layer 2, layer 3, layer 4, layer 4, layer 5. I mean, it is not always necessary that number of instructions should be equal to number of layers. It all depends how your container will get created. The container will take it, and what is the driver that is using. Here you can see it is using overlay 2. This is a driver that we can see, and the location of this is var lib docker var overlay 2. If you go to this particular location, cd to this, you'll see this, all these layers are here, all these images layer, like, you know, this may belong to one layer, one image, this is another image, maybe this is another image. So this is how these images get created. So image is basically list lot of collection of layers. Okay, and each layer basically plays a vital role. I mean, it is something like, you know, it is something like this. Say, let me draw this as little, or let me redraw it. So your layers will be something like this. Okay, this is one layer, layer 1. Just give me 1 second. Layer 1, and this will be layer 2, layer 3, and layer 4. Just imagine this is one image. There is another image, okay, that has also its layer. I'll say layer 1 of image A, layer 1, layer 2 of image A, and something like that. Okay, I'm just naming it, layer 3 of image A and layer 4 of image A. Okay, similarly we have layer 1 of image B, okay, layer 2 of image B. Say for example, layer 3 of image B is same thing as layer 2 of image A, something like that. Okay, whatever we are doing it here, some package we are installing, this same. So they also can share the layer also, that is also possible. Okay, it is not going to duplicate create the same stuff, because Docker is a smart guy. It's not going to consume a lot of your space. If something is already done, like, you know, in a previous image or something, it will lock that and it will reference from there. Okay, that is also possible. Okay, so layer, I'll say 3 of B and layer 4 of B. Okay, this is how your image get created. 4 of layer 4 of B, right? And this is layer 2, right? This is layer 2 of B. All right, so this is all your images got created. Now container will get created from this image. Say for example, this is container 1. It is got created from this particular image. This is container 2, that is got created from this particular image. Okay, all these things are readable. It's only readable format. All these things are readable. All these things are read only. Okay, all these layers are read only. When you create container out of it, when you create container of this image, there is a tiny writable layer get created on top of it. There is a tiny small writable layer that is get created here. What I'm trying to tell you, Do you have any container running? Let's see. Or can I clean everything and do it fresh? Let me clean everything. Docker ps. Yes, there is some containers are there. So what I can do? Let me clean everything because I don't want to confuse you folks. So docker stop. Stop what? I'll stop this container. This container. Just give me a second. Let me clean my slate and then we'll start. Yeah. So what we'll do docker system prune --all. So you can see all the images are gone. You can see all these layers are gone. Can you start? Now you are getting it, right? So if I do ls-l here, and if you do where I am right now, okay, I'm inside the directory. I have another session as well. Yeah. If I do ll here, you can see all these images are gone. My output is blank. Everything got deleted. So that prune is basically deleting all these layer. If you delete the layer, images automatically get deleted. Image is nothing but a collection of layers. Alright, now if I go ahead and say, for example, let me go and run something. Okay. I'll use Alpine image. Let me see. Yeah, docker run command that I'm going to use is, the lab is in my GitHub. You can follow it. Okay, so we are going to create a container that is named as a demo container, and it is using Alpine 3.20. Alpine is a image. It's a Linux specially designed for. It's a special Linux specially designed for container. Alpine Linux. Alpine image that we call. It's very tiny, very small, and as such is a shell that I'm giving to this guy so that it has some process running. So if I go and run this particular command, docker run, and before that let's verify docker ps, nothing, docker ps -a, nothing, okay, docker images, nothing. So our slate is clean. Let me run this command. It says unable to find the image locally. So what it will do, it will download from where? Docker hub. It's downloaded, and I go inside the container already. So I'm inside the container. You can see here, this is my prompt got changed. Okay, how to go again inside? If you run this in background and do docker exec, right? I have explained you that command. That also one of the way, but I just want to show you that I'm inside the container right now. If I go to my another prompt right now, this is my another prompt, right? This is another terminal, right? Remember we took two terminals. This is another terminal in my base machine. If I do docker ps here, docker ps, so I can say yes, there is a container running with demo container, and right now I am inside that container. Cool, everyone is with me? No one is getting confused, right? Are you with me so far? Making sense? We have created a container, we just landed inside that container, and I have showed you, yes, there is a container running. So now what I will do, I will create a directory here. I'll say mkdir data ls. You can see data got created. Yes, it got created. Data is there. Just cd to that data, cd to /data. Everything I'm doing inside the container, not on the base machine. ls. If you want to verify it, you can go here and run ls here. You can see there is no data, right? Data directory we are creating inside the container, and I am right now inside that data directory. And let me create a file. I'll say echo. I'll say hello. We are learning. I don't know what is the spelling of learning. Learning storage. Okay, and I will push that output to storage.txt file. Is the file got created? Yes, it got created. Let me see. I'm able to see the output. Cat. Yes, I'm able to see the output. Let me exit from here. When I exit, I came back to my base machine. Alright. Is the container still running? Let me see docker ps. Container got killed. So that is one of the things that you need to take care when you are at docker prompt inside the container. Don't run exit or something, because that process will exit. What is the key combination that I have told you last time? What we need to use if you want to come outside from the container? Control plus P plus Q. Okay, always remember, if you don't want to kill your container, kill your process and come out from the container, you should not type exit, you should type control PQ. Okay, you will come out from there. Control plus P plus Q. All the three key, you need to press it. But anyway, so the docker, if I do docker ps-a, docker is right now exited, means stop status. What we'll do, we'll turn on this container. How to? Docker start and the container ID. That's it. Container got started. Let me verify it. PS, only PS. Yes, it is running from last 3 seconds. Perfect. Now let me go inside it. How can I go inside now when the container is already running? Docker exec -it, right? What is I, what is T? I have explained you last time in much detail. Okay, and I need some shell, so I'll ask give me a shell sh. So if I go here, I can see I'm again landed inside the container. If I do ls, yes, is the data is here? Yeah, data is here. cd to data. ls, my file is here. Yes, my file is here. Cat file.txt. File, or no, sorry, storage.txt, right? Storage.txt. Yes, I can see the message. If I do control PQ, I'll come outside from the container. And if I do docker ps, my container is also running. So the point I'm trying to make here is why I'm showing you all those things. Just to make sure when you create a container from a image, there is a tiny writable layer inside the container that got created. Over this writable layer, we have created /data. Okay, and everything is getting created inside this writable layer, because these are the read-only files. You cannot create anything on these layers. It's just a read-only thing. And inside data, we created some file and we are able to see that file. So what is our observation? Our observation is in this writable file, when you stop your container and when you start your container, okay, your data is there. Your data is there, right? Your data is there inside the writable layer. Perfect. Okay, but say for example, because of any reason my container got deleted. Let's delete that container. Okay, let's remove that container. All right, so let's do one thing. Docker ps. First I need to stop it, so I'll say stop. Docker stop and the container ID. Container got stopped. Come on. Yeah, it got stopped. And then I'll do docker rm container ID, container name or ID. Docker container got deleted. If you do docker ps, nothing. If you do docker ps -a, nothing. Now, is the image is available here? Docker images. Yes, image is available here. Same image is there. Now let's create the same container with the same name, with the same image, using the same image. I'll run the same command. Where is the command? This is the command, right? This is the command. Docker run -it name demo container alpine 3.0. Alpine 3.0 is already here. So this time it is not going to download from the Docker hub. Directly my container will get created from this image. Yes, I'm inside the container. ls. Oh, data is not there. Data is gone. So what is our observation? When you stop and start your container, your data is there in the writable layer. But when your container, I can say, when your container deleted, okay, and you recreated using same image, same image, same name, everything is same, but your data is gone. Is my observation is correct? Is this correct? This is what happened, right? Yes, no, no, yes. Right? So what is point I'm trying to make? Your writable layer, okay? Your tiny writable layer, this writable layer depends, life is dependent over the life of container. The moment container gone, your data gone. Is this a good thing or bad thing? Obviously a very bad thing, because data is new oil, right? Data is very important thing for me. If my container is getting deleted, what do you mean? My data is gone. Why should I containerize my application then? Right? This is not good. This is not good for some of the application. This may be not bad for some of the application, depending upon the use cases. But if you think that my data is very important, okay, if my data is very important, then you need to save your data. You need to store your data in some way, so that the life of the data, or the life of the storage, I can say life of the storage, independent or not dependent, or we can say not depend over the life of container. That's it, simple. I just want this thing, right? Even if your container got deleted, that is fine. Containers are ephemeral, but your data should not be get deleted, right? So this is where the concept of volumes come into the picture. You need to create volumes. Volumes is very simple concept. It is something like, I'll give you a very simple analogy. These are not temporary container. Container can come and the container can go, like, containers are ephemeral sometimes. When we discuss microservices, Preeti, you will understand what I'm trying to make. But temporary containers are different. Temporary containers are something that got created by Docker when it is creating image out of by reading Docker file. But now my image got created. I'm creating content. My application is running here. But my application is writing some data. That data is getting written on a writable layer. The problem with this writable layer is, the default writable layer is that when you stop and start, that is fine, your data will be there. Stop and start means shut down and start. But because of any reason, if your container got deleted, your data is also gone along with your container. That I don't want. I want my data to be persistent, whatever the state of the container. Container can stop, container can start it, container can delete it, whatever the state, my data should be there. For that, we need to understand volume. Volume is very simple. Say this is my laptop. This laptop has an internal hard disk, right? If this laptop got crashed, somebody throws your laptop outside, there are high chances that that hard disk will also get damaged and you will lose your data, right? Yes or no? High chances. I'm not saying 100%. No, RAM is not the correct. RAM, even you stop and start, RAM data will flush, right? I'm giving you the analogy, correct analogy. Just give me 2 minutes, Pawan. Okay. This is your hard disk. If your laptop got deleted or crash or something, there are high chances you lose your data. But somebody is smart. You'll say, okay, what I'll do, I'll store the data in my pen drive. Data got stored and I'll put my pen drive at safe place, or maybe pen drive is here. Even in that case, if the laptop got crashed or deleted or somebody, your data is still here, right? Is the life cycle of data is dependent on the life cycle of your laptop? No. It is stored in volume, a different piece together, right? Different place. it's stored in your pen drive. Pen drive is like a volume. Your life cycle of your data is not dependent upon the life cycle of the pen drive. Okay, and the internal hard disk could you may consider as a kind of a writable layer. Okay, all right, so what we do in container, we create first volume. Create volume. Okay, when volume will get created, attach this volume to container. Okay, and even if your container gets stop, start, rm, whatever, your data will always be available in your volume. Data will be available inside the volume. Okay, so life of your data independent to life of your container. Making sense? So let's create and try to understand. Let me take some questions here.